Welcome. We're going to shift into a new type of test called an ANOVA test. But before there, let's review something that we may be comfortable with already, testing for population means, right? Previously, we saw how to test for population means using one sample or one population or two sample for two populations, right? And so that's old hat, right? We can do Z or T tests depending on what conditions we have, and one sample, two sample depending on the number of populations we have, right? Now, what if we have more than two populations? How do we do that? And so here's an example. So, um, fictitious, of course, but let's say an anthropologist is studying height from people of different races, and they're focusing right now on the height measurements for whites, blacks, Latinos, and Asians, and they seem to be different as they're collecting the data. So they're like, well, maybe I should test the means, and how do the means compare? And so the data is in the accompanying Excel file. Here it is. And so before we get to the data though, it says, let's see, we need to visualize the data and then set up null and alternative hypotheses in words. Okay. And so maybe let's start there. Let's start with the hypotheses. So for the null and alternate, and again, H1 or HA is fine. The null is claiming no effect. Okay, so we're going to say if there's no effect, we would believe by default that the mean heights for whites, blacks, Latinos, and Asians are the same. Okay, we don't know what their means are, right? But we would say that they're the same. Okay, what is our claim then? Well, all it says is that they seem to be different. So for the alternative, we would just say the mean heights for whites, blacks, Latinos, and Asians are not all the same. Okay, and I've included not all the same because a couple of them could be the same, but maybe Latinos are different than as compared to whites, blacks, and Asians. I don't know. Okay, but all we're looking for is some difference. Okay, now it said visualize the data. Okay, this is going to be fun. I'm so excited. We get to make the first and only 3D graph that you're allowed to make in the class. It is a little bit of work. Okay, so if we look at the data, it is okay, so one means Asian, two black, three Latino, four white. Okay, got it. And then it lists, height for different races. Okay, and it goes and goes and goes and goes. Okay, how do we visualize this? Well, we can't do it all. We can't just, highlight the column and do histogram or something because that's claiming there's just one population. We need to separate it by population. Okay, so what I'm actually going to do is I'm going to make this column data into 4 columns. So I'm going to copy the data. So this would be the data for Asian heights, and then blacks, Latino, and white. Okay. And then I'm just going to copy the heights corresponding to each race. Okay, too far. Um, Copy that over. And then Latino. Okay. And then white. Oops. Let's just copy it. Okay, so it is copied. Okay, and now, okay, this is great. So I have it sorted by, race, but then I'm still curious, like, okay, what is the minimum and what's the maximum? Okay, because what I want to do is I want to construct a histogram by hand. I could make 4 separate ones, but it'd be nice to do it all in one chart. So I'm just going to find the minimum of my data set and the maximum. Okay. There we go. And so now I'm just going to make a chart that numbers, or a table that goes from 57 to 78 to 59. And then I'm just going to highlight these and drag to 78. which is right there. Okay, and then I'm going to count, let's say I need to figure out the number of Asian, Black, Whites, and Latinos that fit into that category. Okay, oh, and so now I'm going to do a special command. You maybe have used it before, but I'm going to use count if, okay, and then I'm going to select, it says range, so this is the data that I want selected, so I'm going to highlight the Asian data, and then the criteria would be, it's going to count only if I select that particular height. Now I'm going to introduce something interesting. I'm going to put money signs around the column letter for the data that I selected. And what this does is it's called absolute cell referencing. So I'm going to drag this command down eventually, but when I do the money signs, it freezes it so it doesn't change the data range. Okay, and then I can just go ahead and double click. I'll do it again. I double click the box in the right corner, or you can click and drag once your cursor is a black cross. Okay, and then it counts up the number of Asian heights that have this value. So you can see right here, there's 4 60s in the data set. You can count them by hand to confirm. Okay, I'm going to repeat with the blacks, Latinos, and whites. I'll do it one more time on camera here, and then you can do it off camera. So count if, highlight the data, so the data pertaining to black heights, and then the criteria, what I'm counting is the height value, okay, and then make sure to put money signs around the column letter, so H's in this case, and then you can go to the lower right corner, click and drag, or double click to have it autofill. Okay, I'm going to do the other 2 columns off camera. All right, and here's my completed chart. Okay, now I want to make this into a histogram, really, and that comes by the way of making so I have to highlight the data. I'm going to make a 3D bar chart. Okay, so I'm going to go make a chart, and then the 3D bar chart that I'm going to use is the one where it's kind of layered, where we have I guess the different populations as different colors in sequential rows behind it. And now I'm just going to make it pretty. So to make this thing pretty, I am going to first select data. Okay, the horizontal axis categories should actually be the heights. Okay, we can insert those. And then the series, I'm going to edit these one at a time. So the first series is the Asian data. And then that's okay. That's not going away. There it goes away. Okay, and then black, and then the third series is the Latino data, and the fourth series is the data for the white heights. Okay, there we go. And I want to make that sure that's shown. Okay, all right. So now it's a little wonky. I think if I were to make this bigger, it might show a little bit more clearly. Maybe not. The next thing that I'm going to do is I'm going to do a little, let's see, I'm going to do a little changing. So I'm going to rotate the axis just a little bit. So I'm going to do, go into this option here, effects for the floor. So I just clicked on the floor of the graph, and then side panel opens up and I select the floor effect options, and I'm going to rotate this. Okay. And so you can see I'm just going to change perspective a little bit. Okay, you might have to rotate a little bit more, but this then allows you to get a different perspective of the graph. And of course, we can pretty it up by adding, labels to the graph as needed. But for right now, this is going to do everything that we want to do. So we can see the different heights along the horizontal axis, and then the frequency of those heights for each of the different races. And so you can see there's actually some very nice normality going on here, oddly enough. And we actually see, at least if we compare, the frequency of black heights compared to the frequency of Asian heights, yeah, there's some differences going on. Okay, so the anthropologist in our study seems to have some I don't want to say correct idea, but has some intuition that needs further investigation. Okay, but so there we have our visualization of the data, kind of fun. Okay, returning back to the problem though, we have our null and alternative. How do we write these out symbolically? Okay, well, symbolically, we would, have to introduce symbols. So we would do, so we'd have mu for whites, mu for, let's see, blacks, mu for Latinos, mu for Asians. And each of these would be the mean height for whites, and then blacks, Latinos, and Asians. Okay. And so the null would be, mu for white is equal to mu for black, mu L and mu A are all the same, right? That one's easy. Alternative, they're not all the same, right? How do I express that? Is it just, I can't do, mu like not equals between them. That is incorrect because some of them might be equal. So that is not correct. So what is correct? Well, interesting. We'll have to maybe think more about the alternative hypothesis. But then even bigger than that, how do we test these, right? We know how to test for means, 1 or 2 sample, but we have 4 samples to work with, okay? We could do multiple t-tests, okay? And the benefit of that is we know how to do them, okay? So that's familiar territory. But how do we do them? Do we compare, which groups do we compare at the same time? We have to do them 2 at a time, okay? I think that's about 6 different tests that you'd have to run. Ouch, painful. Let's not do that. So issues with multiple t-tests, yeah, there's a lot of them. And we don't know necessarily which ones that we would need to do, okay? Do we stop after we find one thing that's not equal? Maybe, maybe not, okay? The other issue that is actually more important to a statistician is that each test has an associated error to it, alpha, right? And so the chance of a type 1 error. And every time we do a test, we're introducing error into that test, right? We define the amount of error that we are saying is acceptable, okay? Each test adds that error on, okay? And adds more error into the analysis. Okay, so if we do 2 t-tests, two sample t-tests, each at 5%, we have a 10% error now in our overall analysis. And then as you do more, right, you just keep adding and adding and adding. We do not want that. So what do we do instead? We want to do 1 test overall to see if there is any evidence for a difference present. Okay, and then this is called the ANOVA analysis of variance test. Okay, and then subsequently, if we come back and say, yep, that test p-value is low, we reject the null. Okay, there is some error. Then we can go and conduct a detailed analysis, typically involving t-tests at that point. Okay, but we would do it specifically after we look at the data in further detail. Okay, so that's going to be our strategy moving forward. Stay tuned for details on how we do this.